Hi everybody, Dr. Mandis here, coming at you again with a little bit more gas laws issues. So right now I want to give you some examples of some gas law problems. We've been spending a couple videos here defining gases, deriving some gas laws. Here I just want to go over some of them as in the math form that they come at you in. Alrighty, this is the list of pretty much everything for first year chemistry. It gets a little bit more complicated for AP or second year high school chemistry or your college chemistry. But anywho, these equations, we can kind of eliminate some of these really easily by seeing how they are really part of combined. So I think the easiest way to attack these problems is to not look at the giant list of things, but say, hey, I have two problems here, combined gas law and ideal, which deal with P, V, N, and T. Combine has two sets of data, ideal one set of data, but they're really similar. And so if I just focus on whether I got one set or two set, I could be good to go. Some of these other things like Dalton's laws, students usually don't have too many issues with that because it's something that deals with only pressure. Density of gases is kind of obvious because usually the problem says, density. Okay. Molar volume is a special subset where you're just basically using liters per mole as a conversion factor. And so basically use that with your stoichiometry. It's only applicable at STP. I don't sweat it too much because basically if you want to solve for number of moles, you're going to slide back up here into the ideal gas law. Alrighty. And a lot of teachers, and myself included, focus on molar volume when we do stoichiometry, which is a different unit altogether. You can check that out in some other videos. But anyway, let's make our shorter list. Combined gas law, ideal gas law is our focus for today. These two right here. And first up, we're going to come with ideal. I'm going to tell you that it's the ideal gas law, but I'll show you why in a second. Alrighty. In the ideal gas law, and this problem, I should say, you got moles, we got volume, pressure, and a temp. Sweet. So the thing that you really want to do, because a lot of students get confused, like I know what to do, but I just don't know which equation to use. Well, that's the crux of the matter. Write down your info, okay? If you write down your info, I don't know why I put that all there. I'm getting ahead of myself. But if you write down all your info here first, okay, you can see that, hey, you got one set of data, one set of PVNT data that screams at you the ideal gas law. Once you have that idea down, then jump over here, write down the ideal gas law, and we solve it for n. Alrighty. Since we're solving for n, we're gonna just rewrite the equation. So friend, don't sub. Don't get caught up with your units and the values and the unit conversions and all that jazz. Just solve it for n. Don't write n equals, okay? There's a really, really common algebra mistake that you can avoid by just leaving n where it is and moving away the guys that are the things that are causing you issues, r and t. Okay, divide each side by rt and you're good to go. The reason I don't want you to move n is it's really common that if somebody moves n to the left, then rt stays where it is and they just slide pv down below because pv needs to go down. Well, you can't just move n to the left to be 1 over n. Basically, you screwed up the equation because you messed up the algebra. The way you avoid doing that in the first place is don't move n, move rt. Alrighty. Then we're going to sub in and go. And the number one issue you got to sub for is the r. The r value right here, the r, people say, how do I know the value of r? Well, r is really dependent upon the pressure. Okay, in this case, our pressure unit is in atmospheres. So because we want all our units to cancel and we write all our units in so we can double check all this stuff, we need to use the R value that's 0.08206 because it's in atmospheres, which cancels out atmospheres. R values have pressure, volume, mole, and temperature units, and they're always in liters no matter what. So make sure your volume's in liters. In this problem it is, but not always. Okay, so make sure you're in liters. And always in a gas law problem, your temperature has to be in Kelvin. In this case, it cancels out Kelvin. It's a nice double check. But even if it's not mentioned, remember our gas laws are undefined in degree C. They must be in Kelvin. But anyway, we substitute in all that value. We do the math on the numbers. We do the math on the units. And we end up with 13.1 moles as our answer. Moving on into another problem with the combined gas law. Here we have a new idea. We have a volume that we're given and a pressure, which is fine. Then, hey, see how we have another volume. and, and another pressure. Well, that screams to us that we have two sets of PV and T data. Okay, and if you look at it, we do. Which one's one, which one's two? I always tell my students, well, the first ones should be ones and the second ones can be two. It doesn't really matter, just so they go together. Okay, but anyway, you have two sets of data. You can't say, oh, this is Boyle's law, but screw that, man. Just recognize it's two sets of data. Use the combined gas law. Okay, we're going to use the combined gas law because we have two sets. N and T aren't mentioned, so they're going to cancel. All right. And I'll tell you what, I'm just going to cancel out, as I solve for V2, I'm just going to cancel out and I'll leave T in so you can see why they cancel. Okay, you can either cancel them right away, which is what I totally advise you to do. Just do what I did and just bag them. Okay, and that will get you to Boyle's law anyway. But I left the T in for a reason because a lot of students ask me, they don't understand why it cancels. But anyway, we're going to solve for V2. Again, leave V2 where it is, just like N. Move everybody else away and rewrite what you get. And then sub. It's a lot easier to do the algebra first, then sub. Okay. When you go to substitute, your units will cancel out, and that's when you get back to the t's that I sort of almost forgot. T2, let me highlight that. T2 here and T1 there. The temperature isn't mentioned, but it's fair to say that the cylinder of compressed gas isn't changing in temperature because the temperature isn't mentioned. If the temperature was changing, it would be mentioned in the problem. Sometimes they say it's constant, but sometimes they just leave it out. Okay, and so if T2 and T1 are the same temperature, some unknown temperature, but the exact same value, then they would cancel because whatever this value is divided by itself goes to 1 and they cancel. My advice is cancel them up front at the very beginning of things that are mentioned, but I'm just leaving T in there so you can just sort of see why. Alrighty. Moving on into the realm of units down in here, okay, you'll see that the kPAs cancel and you're left with milliliters. It's okay to have volume in milliliters because we're not in an ideal gas law problem where we're canceling out the liters from the gas constant. Right, we're just left with milliliters, and if you look at the math, that's fine and dandy, and it solves for milliliters. Alrighty, so you have two powerful equations, the ideal gas law, combined gas law. Combined gas law, use when you have two sets of data. Ideal, one set of data. Usually, if you're in AP or college chemistry, you're going to use the ideal gas law a lot, mainly to get a number of moles that you can then use into some stoichiometry problem or something like that. Alrighty, anywhere case in some mole concept unit where you were given moles before or grams to moles, now you have ideal gas law, which can be used for moles. And then you just use that mole in some other facet of the problem. Anyway, I'm Dr. Mandis. Hope you like it. Hope you learned something. Have a good day.